All right, so a couple more examples, and we'll move on to our worksheet or quiz or whatever you might want to call it. So we'll get a couple more right here. Keep establishing that identity. That's the only game we play in 2.2. Establish the identity. Now, oops, a little check mark next to it. This is not the first time I've done it. I realized I wrote down my second problem wrong, and I couldn't solve it. So I'm redoing this thing. Yeah. Cool. Simple. So we don't want to mess with that side. Complex. We want to mess with this side. Excuse me. So I'm thinking, look, you got two thingies. And the plus sign in the center. Let's put it together to make it one thing, because that's just one thingy, all right? That's one thingy on the right. We got two thingies on the left. So let's make two thingies into one thingy. And we're going to do that by just let's get a common denominator. You got 1 plus cosine and you got sine. So what we'll do, there's an implied parenthesis around fractions. So let's just give it that sign. But you got to do it top and bottom. You can only multiply by 1. Don't change anything. Don't change it. Don't square shit. Just ones. So now we look over here and go, okay, this one has a 1 plus cosine. So to make it match, we write 1 plus cosine. Now our denominators match. And we can put them together. The whole point. Can you even read that? Jeez. I know I'm saying it, but come on. You gotta be able to at least kind of read it. Well, that's much better, right? Alright, there it is. Now our denominators match, so I'm going to write the denominator in. Alright, we just ran it once. Cool. And now we got sine times sine, that's sine squared. And now we have 1 plus cosine times 1 plus cosine. And that's 1 plus cosine squared. And I'd like to just write it and make sure, just in case we've forgotten, what this will never equal is 1 squared plus cosine squared. It'll never equal that. We FOIL. That's nonsense. That's nonsense. Don't do that. So I'll write it up the long way. You FOIL. First, outer, inner, last, right? Remember that? You learned that. First, outer, inner, last. So now we keep rolling on through this thing. We end up with sine squared of theta. So now let's go. 1 times 1 is 1. 1 times cosine of theta is cosine of theta. Cosine of theta times 1 is cosine of theta. So we must have 2 of those cosine of thetas. And lastly, we get cosine times cosine, which is cosine squared of theta. All over 1 plus cosine of theta times sine of theta. We're getting there. Can you see it? Can you see it? Can you see it? You see it? We want to keep our eyes open. We got to get this new vision going. That like when we see sine squareds and it's positive, we're like, where's that positive cosine squared? Is it around somewhere? And there it is. They don't need to be next to each other. They just need to be on the same line, and they need to both be positive. Well, the sine squared's positive. The cosine squared's positive. It's written in a string like this, so gosh dang, we can actually just do one of these. Be like, let's get rid of that and let's just add in a 1. So when we get to our next step, we got 1 plus 1, and 1 plus 1 is 2 plus 2 cosines of theta. And there's our numerator, just cleaned up. Oh, and there it is. There's that 1 plus cosine of theta that we're going to turn the numerator into. That's going to cancel out. Cool. We get to this point, and now we're like 2 and 2. Let's factor out that 2 and 2, just leaving us with a 1 plus cosine of theta on top and bottom. We'll be able to cancel it out. Here it is. We bring the 2 out, and we get 2 times 1 plus cosine of theta. There's that numerator over 1 plus cosine of theta times sine of theta. And this is the best part of math, I think. Going, yeah, go away. Makes it easier. And now we're left with 2 over sine of theta. And what's 2 over sine of theta? 2 cosecant of theta. Look at that. Bang. That's what we wanted. That's what we wanted. So we got it done. Little tricks. I like this problem. This is a good like test level problem. It's got a couple things involved in it. You got to add some fractions. You got to know a Pythagorean identity. You got to do a little bit of factoring and canceling. I don't know. It's got it all. It doesn't have it all, but oh. Let's look at the next. Oh, this evil problem. It's the evil problem. Let's go through it. I had this written as secant. I couldn't figure out what the frick was wrong with it. Ah, silly. So many mistakes. Story of my life. All right. I look at this problem and go, I don't see anything squared. So I don't see anything squared. That means the Pythagorean identity sine squared plus cosine squared equals 1, things like that. That's not going to be the style. And then I don't see anything to factor. None of the pictures match, which make me start to think like, let's just go sine and cosine. Mike, can we just change everything to sine and cosine? Let's do that instead. So instead of writing in tangent, I'm going to write in sine of x over cosine of x. Now instead of writing cotangent, we're going to write in cosine of x over sine of x. Lastly, down below, we're going to have our 1 over cosine, that's secant, and our 1 over cosecant, that's sine. Now we could just write it like this, just make one big thing and go like this, and then maybe with the multiplication in the middle. Because I mean, isn't that how fractions work? Don't you just put your numerators with your numerators and your denominators with your denominators? So the next step, I'm going to write it like that, okay? Here we go. We're going to have to play that same game. I like adding fractions. Actually, you know what? Let's not add fractions. Let's do a different manner. I don't know if you've remembered this, but you could absolutely, there are many paths. We could add these two things together first, and then we could flip this up and we could multiply. But I'm thinking, let's go a different path. Let's talk about, remember least common denominator? So what's our least common denominator? Cosine, sine, cosine, sine. It's sine cosine. It's freaking sine cosine. So why don't we multiply top and bottom by sine of x, cosine of x? This is called like maybe fraction busting. So because nobody likes fractions, especially complex fractions. This stuff sucks. It's not good. Nobody likes it. We're trying to get away from all this nonsense. But there's one way we can guarantee that we can get rid of all of these 4 denominators. If we multiply by sine of x, cosine of x, so that shit will cancel. So I'm going to show way too many steps here. You don't need to show this many at all, but we're going to bring this one in. We're going to bring this one in, so you got your, write it out all long, sine of x over cosine of x. But now we're bringing this one in. So you get times sine of x, cosine of x. And you see that this cosine and that cosine are going to cancel. But you could have just done this in one step and been like, hey, the cosine's going to cancel, so we get sine times sine, that's sine squared. And you could just write down sine squared instead. But we're showing steps right now, because I had understanding at the beginning. And now we're going to do the same thing here. We're just going to make that the numerator. We write it in, we're like cosine of x over sine of x, and then we have times sine of x, cosine of x. Old fraction busting. It's kind of nice. And then lastly, we're going to bring in over that, I'm going to turn it around too. The cosine of x times sine of x down here, that part, just wrote it as over sine of x, cosine of x. So when we bring this in, it just goes to the top. Well, that's the same picture with the same picture down there. So let's start cleaning, huh? Let's start cleaning this stuff up. Let's get the red out. Go, yeah. Get out. And look at that. Dude, we got rid of frickin' everything. What's left over? We got sine times sine. That's equal to sine squared. Plus, what's left over here is cosine times cosine. That's cosine squared. And if you don't know sine squared plus cosine squared equals 1 by now, I just don't even know what to do with you. Yeah. And there we go. Nailed it. This is another good problem. Not too many steps. If you would have added fractions, it would have added about 1 to 2 more steps. A little bit longer. But there's many paths through these. So find yours. All right, I'll see you in the next.